Hi, college algebra student. This video is for chapter 2.4, complex number. It's a shorter section, so it's devoted to a particular types of number called complex number. The beginning of complex number begins with introduction of a number called a imaginary units, I square. So this I squared, this number I is very interesting in that we don't know what it is, but if you square it, it's -1. So far, if you are to solve this equation x squared equal to -1, there's no real solution, right? There's no number when you multiply them, they're equal to -1. So because it doesn't exist, we just imagine that this number exists, and we call it I because it's imaginary. So the way you define the imaginary number is it satisfies this equation of I squared equal to -1. So I would equal to, you can think of it as square root, the principal square root of -1. So I is square root of -1. But the main definition is if you square this number, it would become -1. So call it the imaginary unit. So what is a complex number? The complex number consists of two parts. One is the real part, like 5, -2, or 1.7, plus another real number, and then times I. So I is an imaginary unit, but you can have 2I, which is also imaginary. And if you combine it with a real number, we call this types of number a complex number. Okay, so example would be 3 plus 2I. So this is the real part and this is the imaginary part. The imaginary part consists of I multiplied by 2. Okay, so this we call it a complex number. And this form of A plus BI is the standard form of a complex number. So example 1. If I have a number that is square root of -25, can I write it as a complex number? Now square root of 25 has no real part, so it'll be 0 plus what is square root of 25? -25. I can write it as square root of -1 times square root of 25, right? Square root of 25 is 5, so it'll be 0 plus 5. Square root of -1 is I. So this is the complex number. 0 plus 5i. Or sometimes we can write it as 5i. That's also good. What about 3 minus 2, square root of -16? Okay, so now 3 minus 2, you don't do this. The 2 is a multiple of this imaginary part. So this is the real part. So you keep the 3 and you write 2. So square root of -16 can be written as 16 first and then a square root of -1. Why? Because this would be imaginary. So square root of 16 is 4. So it's 3 minus 2 times 4. I. We recognize that square root of -1 can be denoted as I. So that would be written as 3 minus 8i. Now sometimes if it is not a perfect square, you can have some root, like radicals, left over also. So that is also a complex number. Second part of this is graph this complex number A plus BI in a complex plane. Okay, complex plane. Why? Just imagine if you have a real number like -2 or 5 or 6, you can graph it on a number line, right? A real number can be graphed on a number line like 5. Where would it be? You will have 0 and then 1, 2, 3, 4, 5. Okay, 5. So this is its position on the number line. But if I have a complex number like 2 plus 5i or 5 plus 2i, where do I graph it? Right? 5 plus 2i. So the real part is 5, but how do I graph the 2i? So what happened is we would define something called a complex plane, not a number line, complex plane. So we still have the number line x. It's still 0 in the middle, But we'll draw a vertical line that represents I. So instead of Y, we say this is I. 1 means 1I, 2 means 2I. Negative means negative 1I. Okay, so this is negative I, negative 2I, like that. So this is the old number line 1, 2, 3, negative 1, negative 2, negative 3. So if I am to graph negative 2 plus 3I on this plane, where should I go? I would say I'm going to graph the real part, which is just like the number line. This is negative 2. It will be here. But 3I is on the y-axis, or well, actually, I should not call it the y-axis. I call it the I-axis. 3, 1, 2, 3. So it will be negative 2 and then 3I. So this point represents negative 2 plus 3I is here. And in a regular rectangular coordinate plane, this corresponds to negative 2, 3. But this, if it is on a complex plane, it represents a complex number. Part C is how do I do operation of a complex number? I invent some new numbers. For numbers, we to do add, subtract, multiply, divide, right? How do I add and subtract them? So for add and subtract, the idea is to combine real number terms and then imaginary terms. Okay. For multiply and divide, we use FOIL, but we must simplify I squared to negative 1 because that's how it's defined. And for 3, if I am to divide two complex number, we use something called the complex conjugate of the divisor to the numerator and denominator. Okay, so let's go through them one by one. First is add and subtract. So I have one complex number, 3 plus 7i. I subtract another complex number, 5 minus 2i, and I add a complex number, 8i only. So I can think of them as, I being a different terms. I can combine like terms, the constant term, and then I combine the I terms. So minus 5, I need to distribute a 1 here, plus 2i, and then plus 8i, right? So I would see 3 and 5 are like terms. So 3 minus 5 would be negative 2. And what about I? I have 7i, I have plus 2i, that's 9i. And then I add 8. 9 plus 8 is 17i. And that is a new complex number of the real part and the imaginary part. So that's how you add and subtract, pretty straightforward. How do you multiply? So here I have an expression of complex number 4i, which is a complex number multiplied to 7 plus 2i. I also have two complex numbers that consist of, real and imaginary, and they are multiplying together. So I'm going to multiply this by distributing. So 4i times 7 is 28i. 4 times 7 is 28. Plus 4i times 2i would be 8i squared, right? Then add. So this is 2 plus I, 2 minus I. So I have to do FOIL because both of them has real and imaginary part. This one I don't need to because I only have the imaginary part on one of the complex number. So 2 plus I would be 2 times 2, and then 2 times negative I times 2, I times I. So 4 minus 2I plus 2I, I times negative I is minus I squared. Okay, so we can combine like terms now. Look at all the i's. These 2i and minus 2i cancel. I only have 28i left over. What about real parts? So I have some I squared, 8i squared minus an I squared. I should have 7i squared, right? But remember, I squared is actually negative 1. So I would have negative 7. So just replace it by negative 1 plus 28i. And that's the final answer for this 2 multiplication. And I wanted to bring your attention to 2 plus I, 2 minus I. They are a real and imaginary and a real and imaginary, these two numbers are related in that they are called complex conjugate. One is add, one is subtract. So complex conjugate are a plus bi. So this is a complex number, but a minus bi would be complex conjugate. Why is it called conjugate? Because when you multiply them, the I terms goes away. So you see how there's no more I terms. You only have 4 and an I square, which can be converted into a real number. So if you multiply them, they become only real number. Okay. So there's some special things about complex conjugate. And we'll use this fact to do division. For example, I have 6 plus 5i divided by 4 minus 3i. You can think of it as being a fraction. And we are not allowed to have fraction with a denominator of a complex number. So I want to get rid of I in the denominator, so I'll multiply the complex conjugate of the denominator. The complex conjugate of 4 minus 3i is keep the real part, but the imaginary part you change sign. If you begin with minus 3i, you do plus 3i. So do 4 plus 3i. Okay. So then, so the denominator become, 16. You FOIL them, 16 and then plus 12i. And you notice that you turn around and do minus 12i. So the I always goes away. And then you have to do minus 9i squared. The top you still do FOIL. So 4 times 6 is 24. 6 times 3i is 18i. They are not conjugate, so you have some I left over. 5i times 4 is 20i. And then you have 15 with 5i times 3i is 15i squared. Right? So this is similar to you doing FOIL. The bottom would be 16 minus 9 times negative 1. Anytime you see I squared is you write as negative 1. And then the top you would say, well, I have 24 and 15i squared. This is an I squared. So it'll be 24 plus 15 times negative 1 plus 18i and 20i's would be 38i. Right? So I only have I in the top, but no I in the denominator. 16 plus 9 is 25. And then the top would be 24 minus 15 is 9 plus 38i. I can split it into two parts, so I have a real part of 9 over 25. And then I have an imaginary part of 38 over 25i. So this is the way that you do division. You begin with two complex numbers dividing each other. You end up with a complex number of a plus bi. Okay, remember you use complex conjugate of the divisor. Multiply top and bottom with the same thing to do a division. The last part of complex number is dealing with exponent of complex number. Now, by definition, I squared is negative 1, right? So I cubed would be I squared times I. So that would mean negative 1 times I is negative I. I to the fourth is I squared times I squared, so that's equal to 1. So how do I do I29? So anytime I have 4 to the power 4, it's going to be 1. So the good thing would be just to split up as much I to the 4 as much possible. So I have 29. So what is the closest multiple of 4? It will be 7 times 4 is 28, right? So I would have 7 of these. You can do dot 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 if you don't want to. And then after that, so this would be I28. We really don't care how many they are, just dot dot dot. There's 7 of them, right? 7i to the 4. Well, I should not say 7. So there's 7 times of it. um, and then time